Key number one is Mark. Key number one is ID 1. Key number one is date of birth. Date of birth talks about key number 1. Atlanta talks about key number 1. GPA, actually we took address out, so I'll drop that off. GPA talks about key number 1. What if I added school there? Does the 4.0 talk about the key, or does the 4.0 talk about the school? It's probably still the key, but we're getting kind of fuzzy at the moment. We're getting kind of fuzzy. Let me see which one they used. Address. If I had a key out here, phone number that I had at that address, is that really a phone number describing the key, or is it describing this right here? Yeah, possibly. If I had here's one. Cell. Because there is no other. I'm an iPhone guy, sorry. I've had one since they came out. They came out in October of 2000 something, and I got mine in November. So I've had one since the beginning. So. I actually do have a Samsung Android thing. I don't call on it, but since I'm taking the Android programming class at LSUS right now, I've got an Android. So if I put the model here, is the model really talking about the key, or is the model talking about some other piece of, some other attribute? Some other attribute. See, this doesn't really make sense here. For one, model for my home? Nah. But what I'm trying to get you is, as you get progressively up the normalizations, they get harder to see. So when you get into 4th and 5th and 6th, they're getting really picky. 3rd makes pretty good sense. It's when you've got data that just doesn't really fit. Like for instance, if we had address, if we had ADDR1, ADDR2, city, state, zip. This is really about the rest of this. They're talking, each of these are talking about this whole and not really about the key up here. Does that make sense? So when that starts happening, that's a clue to you that something's wrong. And that's all normalization is. All normalization is a clue that something's not right about your design. The reason that, we've already talked about the reason this would be bad is because my address changes. So if I had my address on this line, and let's just put it up here, let's just say all those fields are there. If my address changes, well, you could update it and put the new address in there. But what did you just lose? You lost something. What did you lose? If I change my address, what did you lose?
The old one?
The old one. So when you call me and say, where's my package? I ordered this from Amazon. Where is it? Well, I shipped it to, I think I shipped it to that one because I lost the old one. So now I don't have this nice table down here with all your addresses and different keys and go, oh, we shipped it to this one. Well, I moved. Well, you didn't tell us. So when it comes back, we'll ship it to you again. See, that's what that's for. Just simply putting it down here gives me that ability. So when you're learning normalization, normalization is techniques to make it easier on you when you get too far down in the project to start changing everything. If my application's in production and I start having this problem, I'm in trouble. Because now I've got to change my table structures. Which means what? Somebody's got to change their code. And so it starts snowballing. Everybody's got to start changing things. Why? Because I missed something. If I had gone through and said, hey, let me just check and make sure I got first, second, and third normal forms. Okay, cool. I'm good. Everything looks good. It would have saved me a whole lot of trouble. So that's why you learn normalization. Now I'm going to show you one thing that we do that has to do with denormalization. So I said earlier that denormalization has to do with the fact that sometimes performance is more important than the structure of the data. Okay? For instance, how many of you know what a log file is? Oh, come on, log file? Okay, so, let's see. Okay. No log files. That's a good example. Dang, you stumped me. Now I gotta come up with a different example. Let's say, let's do this. A list of transactions. Y'all all been to a bank or an ATM? At some point in your life, you actually handled money, right? Cool. Everybody got a debit card? Take money out of the ATM? So somewhere in the system, they've got a big old transaction table. And they're going to record a whole lot of information. They're going to record who, what, when, maybe where, all this kind of information. Now, I could, when designing the database, normalize all that information. I could have a who, and I could have wheres, the who's and the wheres, and the whats maybe, and they're all connected somehow with some relationships. At least the who's and the wheres, because I know where my ATMs are and stuff like that. And so whenever a programmer has to deal with it, they've got to deal with all this relational stuff. And if you've done your job with your database, there's database integrity. So you put primary keys, and you might have put some what we call referential constraints, meaning maybe I can't be in this table unless I'm in this table, and I can't be in this table unless I'm in this table. That's called referential integrity. And so when you do things like that, so like if you have parents who have children, I can't have a child unless I have a parent. Last time I checked. So this is dependent upon that. So for me to put a record in the database for a child, I've got to put the parents in first. Because if I try to insert them here, your referential integrity is going to go, and it's going to make me stop, and it's going to give me an ugly error. So I've got to put Holly Summers, my mother, and then I can be in there, because she had a child. Actually, she bought me. I was bald. I'm adopted. I like that. I was bald. So the other three children, my two brothers and sister, they're nothing because they paid for me. They picked me out of a lineup. They really did back then. They took them through and they'd line up the kids. Anyway, So, so if you do this kind of stuff, then as a developer, I've got to make sure I put it in here first, and that's successful, then I can put it in here first, and that's successful. But what if I fail going into here? Then things go wrong because I can't put it in here until I get it in here, and it causes a problem. And when you're talking about bank transactions, you don't want to sit there and wait all day for the computer to go, "Ooh, I gotta put it in the first table, the second table, the third table," and get all that done. So what we'll do is flatten it. We'll take those tables and we'll flatten it into one table. And we'll consciously make the decision to ignore some of the normal forms because it's faster. It's typically data we're not updating and we're not deleting. We're simply inserting. So transactions, when they go in, now we could possibly go back and void a transaction, so we might do a little bit of updating, but it's not heavily updated. The main thing that we're going to do is insert the transaction every time somebody does one into the table. So this table, a denormalized table, will usually be what we call wide. It'll have a lot of columns. That whole third normal form where, you know, this column doesn't really talk about that column, you know, it should talk about the key. Forget that, it can talk about that column. We'll put it in there because it's easier, it's faster. The whole idea with your ATM transaction is get your money and get out. So they'll do that kind of stuff, and that's denormalization. Normalization, remember, normalization is about getting your data right so you don't have headaches later. But sometimes, all right, there's a law out there that says don't speed. But sometimes you're allowed to break the law. So the fire truck, we don't make the fire truck or the ambulance or the police officer follow the speed limit. Why? Because we want them to get there as quickly as possible. But typically we want most people to follow the speed limit. So most of the time we'll do the first three normal forms.